Kubernetes? It is an open source container orchestration system for automating your software development, scaling, and management. So these applications are basically all containerized applications that we are talking about. So back in 2014, it was released by Google as it was developed by them. But now the project is maintained globally by contributors and it is officially trademarked by CNCF. Okay. So before we proceed with this video series, I would request all of you to look into the video that I have prepared. It would be available in the I button, which was the basics about what virtualization is, what containerization, the basic differences, and how you use Docker to build and create images out of it. Okay, so it gives you a hands-on of how you create a containerized based application that is necessary. Moving ahead, so what are the offerings and benefits of using Kubernetes? Well, talking about a modern day applications, one important factor is scalability. Kubernetes provide you with this specific feature where you scale your application up and down with a simple command or UI, and automatically that can be done based on the CPU usage. Next is load balancing and service discovery. So Kubernetes can expose any container applications that you are running using the DNS name or using their own IP addresses through mechanisms or objects called services. So if traffic to a container is high, Kubernetes is able to load balance and distribute the network traffic as per the backend application's capabilities. Then coming to the monitoring and secret aspects. So there are different ways and tools and capabilities where you can monitor your workload that you are running on a cluster. Config management and secrets. So Kubernetes lets you store and manage sensitive information such as any kind of credential, tokens, SSH keys. You can deploy and update the secrets and application configuration without kind of rebuilding your container images and without exposing the secrets in your stack configurations. Talking about storage management and orchestration of storages, Kubernetes allow you to automatically mount a storage system of your choice. It could be a local storage or it could be any storage that is being provided by a public cloud provider. RBAC and security, so role-based access control, security, how you want to keep your entire cluster and environment secured. Those capabilities are also available, and specifically like with use of AWS IAM roles that can also be added and implemented through proper object creations that are available, which we will discuss in our forthcoming classes. Then self-healing capabilities. So any kind of containers that the containers that are workloads running on your cluster, if it fails, Kubernetes replaces them, kills those containers, those which doesn't respond to your user-defined health checks, and doesn't advertise them to clients until they are ready to serve. There are many more capabilities that are available, and I would suggest you go through the documentation of Kubernetes. Next. So in order to understand how a Kubernetes cluster works, let us try to draw an analogy of how a shipbuilding port or a cargo shipment entirely operates. So it's basically how the port authority and the cargo ships, they work hand in hand together. As you can see on the screen, on the left side is basically the central control plane of the port or the entire port authority, from where different cargo vessels they load themselves with those containers and goes out for delivery. Say for example, how a typical port operates. So there has to be a harbor master's main office which controls everything about like orchestration of these entire systems, the cargo ships, which ship to come and which ship to go and everything. So it controls all the different aspects of the operation. So in case you need to know which ship is coming, which ship is going, so there has to be a database that needs to be available or a registry. So it keeps information about the particular ship X who is the captain, and how many containers are being going. So basically those consignments, those details. Then there is a requirement of a shipment manager who basically assigns that this container goes to this ship. And this definitely happens under the supervision of the harbor master. Then comes a bunch of offices which basically looks after the fleet management and multiple other factors uh, that checks and the overall ecosystem works. Now coming to each of those cargo ships, so a ship in order to run should have a captain and the entire storage facilities where you can place your goods and containers onto them and let it go to the destination. So that is needed, and also in order to have the ship to communicate with the port authority, as well as if needed one cargo ship can communicate with the other cargo ship with the help of proper communication channels. So this analogy helps you understand how Kubernetes operates. Let's go quickly to this slide. So the Harbor Master Office, the main office, which I was referring to in the previous video, previous slide, is basically the Kube API server, which acts as the brain of your cluster. So as on the left side, you can see the port authority which we are talking about is basically a master node or a control plane. So it could be a virtual machine, or it could be, if you're running the cluster on your on-prem, it could be a server, a bare metal server. And on top of that, important components that are mentioned on the left side needs to run in order to make that node behave as a control plane or master. The port authority registry, or the database which we are talking about, is now handled by this HCD. So Kube API server, it's the front end of your Kubernetes control plane that exposes the Kubernetes API, that allows that basically handles any kind of internal or external requests. Talking about the HCD, it's a distributed key value store that stores the metadata of the cluster. So it comprises of multiple instances within multiple instances that takes care of the entire information about the cluster, that how many pods are running, what pods are running, what configuration. So I will come about pods and what basically it stores the information about the workloads. Talking about Kube Scheduler, it watches closely for any kind of newly created workloads with no assigned node, and it assigns your corresponding containers to a specific available node. Now talking about Kube controller, so they run kind of a control processes that frequently checks on the basis of a predefined state what is the current state of different objects or components that are available, and accordingly ensures that the state is preserved. So Kube controller can comprise of node controller, replication controller. So node controller, what it does, it ensures that the health, it checks the health of the worker nodes. If in case a worker node it becomes faulty, it replaces it with a new node. Replication controller also ensures that the number of pods or the workloads containers that you want to run, the number remains intact as you specified. So likewise, there are other controller capabilities that are available, and that can be found in the documentation as well. Coming to the definition of description of the worker nodes. So the worker nodes each comprises of the pilot or the captain, which is the kubelet. So kubelet, what it does, it acts as an agents that run on each node, and it ensures that the containers are running in a pod and communicates with the control plane. Talking about kube proxy, so it is associated with the network proxy that runs on each of those nodes in order to ensure connectivity between each of those containers. And the important thing, which is a container runtime. It could be Docker, container, or cryo, depending upon how you are using what it can be any runtime where you can run your container workloads, basically the applications. Okay. Next, let's move on. Uh, let's try to understand as we have defined. So on the upper box that you can see on the top, It's basically the control plane, and the nodes, as you can see at the bottom, these are the worker nodes. Okay, so how things work Kubernetes in ecosystem. So as a user, say for example, you specify that I need to create a pod with name ABC. So what is pod? I will go back here in order to explain it. I missed it. So pod is a collection of containers. So it could be one or more containers. So depending upon what type of workloads you're creating, they are logically grouped together in the form of a container. So it could be containers, it could be volumes that are mounted on the container. So in together as a whole, we are using the term as pod. And that's the structural basic unit of Kubernetes ecosystem. Now, so as a user, you can request that, hey, create a pod with name ABC where you're running your container workloads. The request would hit the API server. The API server, meanwhile, what it does, it basically checks with the high availability key value database to ensure that none of the pods are running with the name ABC. And it acknowledges back to Kube API server. And then Kube API server instructs the scheduler to let's go ahead and schedule this pod. And the pod accordingly gets scheduled in one of the available nodes. So the main job of the scheduler is to create rank of nodes on the basis of what is the requested pod and what are the resource requirements. That means in terms of memory and the CPU, and it checks that which is the available node or the most suitable node to run this specific pod application. So it kinds of distributes the pod on the basis of the available resource. Okay. And once the pod is created, the user gets an acknowledgement. Okay, my service is my specific workload is ready. Now, how control manager works. So I'm in these slides, I'm trying to demonstrate, I'm trying to show you how the control plane each of these components work. So let us consider a cluster where there's a control plane with two nodes, worker nodes, and how control manager, basically the node manager, the node controller works. So for example, if one of the node while running, due to some issues, underlying issues, could be the VM specific issues or anything, if that specific node dies, then the node, they ensure, the control plane ensures that basically the node controller ensures that that specific faulty node is replaced by a fresh node. And meanwhile, the workloads can come again back on top of that, run on this newly created node. So there are certain mechanisms how the scheduling could be done. I will cover them in the forthcoming sessions. And finally, let's try to see how the kubelet or how the kubelet works, and along with that, the kubeproxy. So what the kubelet does is, as an agent, it registers to your API server, and through that, Kube API server is able to understand, okay, my node is connected and the node is running. Next, what it does in case of any kind of the other the kubelet, it's the primary node agent, as I mentioned, that runs on each nodes. And it, once the registration is also done, the node becomes a part of the cluster. It ensures that the containers are running and healthy. Okay. So it will check, okay, if this pod is assigned to this specific node, it will ensure that, okay, this pod has been assigned, and it will ensure in that way that the pod is kept running unless and until there is some underlying issue that's coming up. Okay. Now kubeproxy, what it does, as I mentioned, this is one node and this is one node. Say this is a pod, there is a pod which is an application pod container running on this node, and it needs to access a database container possibly available running up and running in this node. How it would be done? Through the help of kubeproxy. It's kind of the network capabilities and connectivity it provides. Okay, so That's all for now, and I will come back with the next video where I will be talking about what pods are, what services are, and what are the different types of services available. And there are other available K8s objects, and what are the purpose of each of them, with some of the hands-on. So keep revising, going through all these documentations available in the Kubernetes website and the public documentation, and feel free to put a comment if you have any specific question. See you in the next lecture. Thank you.